let's do another example here. So how do we start it off? Again, the first thing that we need to do is we need to set the scale, right? How much does each grid line measure? Okay. In this case, we are going to need to set the scale for the y-axis a little bit differently than before. Because notice, we've got a new and higher midline. So now our midline goes all the way up to 8 on the y-axis. And our amplitude goes 4 units above that, right? Our amplitude is 4, which means that our maximum is going to be all the way up at 12 units on the y-axis. And our minimum is going to be at 4 units on the y-axis, right? So if we count our grid lines, we should only have about 10 or so, right? Obviously, if we set the scale to 1 unit on the y-axis, we're going to be a little bit short of getting to 12. So let's just make a real simple fix. Let's set the y-axis scale to 2, right? And that way we'll have plenty of room to draw our midline, our maximum, and our minimum. Now for our x-axis scale, that's the one that's a little bit trickier. But again, all we need to know is the period of the function and set that point exactly 16 grid lines from 0. How do we find the period? We take the frequency, which in this case is 2, and the period is equal to 2 pi divided by 2. Can we simplify that fraction? In this case, we can. The 2's will cancel out, and our period will be equal to 1 pi. So that's exactly what we type into the box, right? I'm just going to type in 1 pi. We hit done, right? And notice now we've got plenty of room to graph everything vertically. We've got a 12 there, and we've got our 4. And now I'll be plenty good if I just click this point that says pi units and set it at 16 grid lines along the x-axis. So now I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That will represent exactly 1 period length. And I do that again because now I can break it up into quarters really easily by counting out 4 grid lines. Okay. What do we do now? Right? We know our maximum already. We know our maximum is right up here at 12. We know our midline. Our midline is right here at 8. And we know our minimum. Our minimum is right here at 4. What we need to know now is where we start, where we finish, and where we go in between. And that is a fact that comes from the specific equation that we're looking at. Meaning, are we looking at sine or are we looking at cosine? For this equation, we see that sine in there, so we know we are looking at sine. We're not looking at cosine, so we don't need to know that pattern on the right. So what about sine? Sine starts at the midline. So in other words, when x equals 0, we are at the middle of the function. The middle of the function is 8 units, right? So when x is 0, y is 8. That's our first point. Where does sine go from there? At a quarter of the way through, the sine will be at its maximum. So at exactly our 4th grid line, we're going to be at the maximum point, which is going to be all the way up here at 12. So that's our second point. 4 grid lines over, where will we be? Halfway through, sine is at its midline again. So if we go to our 8th grid line, now we're back at the midline. Keep going from there. Where do we find ourselves? 3/4 of the way through the period, sine is at its minimum. So if I go to my 12th grid line, I go to my minimum on the y-axis, which is 4 units. So that's my 4th point out of 5. And in sine, we finish back where we started at the midline, right? So once I get to the 16th grid line, which I've labeled as being pi units, right? I find myself back all the way up at the top. Right, this is the point I click. Hold on a sec. I misjudged a little bit. Let me, I went 1 too high, so it should be at 8. There we go. Okay, so at pi units, my 16th grid line, I'm back at the midline, right? And that should be good. And we divide the period into 4 equal intervals and work from there.